Okay, so to continue this section, we're gonna go into a little bit of about the middle and how the middle is weighted and the difference between the median and average and how the average can be weighted and how the median isn't weighted. So if we go back to that startup company with those travel times to work, we had 7, right? So what if we had a new employee come in? It's our 8th employee because we're growing, and that person traveled quite far from work to get, I mean, from home to go to work, right? And they took, or he or she took 70 minutes. So the new employee took 70 minutes, and now the data set is 8 values and includes that long trip of 70 minutes. So let's go ahead and determine the median of the new data. Okay, so we will go ahead and step 1 is always to put them in order. So we'll go ahead and put in order. And we'll put 5, 18, 23, 23, 26, 36, 43, and then now this new data, which I'll put in red, 70. And so now we have 8 pieces of data, right? 1, 2, 3, 4, 5, 6, 7, 8. So the middle is still the middle, right? And so here we go. So if we put in order, now we can go ahead and determine the locator. So now we have 8 pieces of data, and the locator is going to be 0.5 times n, and that's 4. So that's the 4th position, right? But because it's a whole number, remember when the locator is a whole number, you take that position plus the one next to it and then divide by 2. Position. Okay, and so then that would mean the median is going to be equal to the 4th position, so that would be 1, 2, 3, 4, 23, 26, and the average, right? So 23 plus 26 divided by 2. So if I put that in the calculator, I would actually get a value of 24.5 minutes. So that's the median of the new data set, not average, median, where half the employees take 24 and a half minutes or less to get to work, and the other half takes longer, right? Our original 7 employees we had 23 minutes, right, as the median. What is 23 far off from 24 and a half? If I said it took me 23 minutes to get to work and you said it took you 24 and a half minutes, what does 1.5 minutes mean when it comes to working? It's a ride up the elevator, right? So it's essentially didn't really weigh much. You would think, whoa, this person's 70 minutes when the largest minutes that someone went to work was 43 and now someone takes 70. That's going to be like, woo, way up there. And actually it didn't really change that much. It only waited a little bit, 1.5 minutes. So we can see that the travel time, let's write a note. So the travel time of 70 minutes didn't affect the original median that much. It did change. I mean, I'm not saying it didn't change, but it didn't really change it as much as I thought it would, right? So why do we care about this stuff? Well, this is why the median is amazing, because the median doesn't get too intimidated by large data. Like, okay, throw in 150 minutes in there. I'm not going to be weighted that much more, and that's what is nice about the median, right? So now let's talk about the same set of data now. And now the new employee has a 130-minute commute. Okay. And how does this impact the value of the mean and median, right? So now you're going to be adding an employee that other employee said, this is too much, I'm not going to drive this far. And another employee says, it's okay, I'll drive double, right? So this person's 130. Okay, so if I went into the calculator, right, I would calculate the mean and median. Right? And you would include all of them, including the 130 minutes, you would actually find that the mean is going to change a little bit to, with it being 38 minutes. Okay. And before, so I'll do that in purple, right? Before the mean, I'll put this in parentheses, right, was 24.86. Okay, and then if we looked at the median of this new set is actually going to be the same as before, because notice that this is weighted, if I go back up here, notice this 70 here is weighted over here. Well, let's say I just change that to 130. Well, it still means that it's an 8 number of data, and I take the fourth and fifth and find the average, right? And so it's still going to be 24 and a half. It just means that 70 turned into a 130. So that would be 24 and a half minutes, right? So in purple, what was the original median? Right, it was 23 minutes. So tell me, which one did it impact more? Right, the average. You know why? Because we're doing an arithmetic operation with the average. We're adding all these numbers up and dividing by how many we have. Not to say that isn't valuable, but notice that with the median, whether it was 130 or 70 that was added in, it didn't change the median hardly by a minute and a half, but it did change the average by like what, 14 minutes or 15 minutes. So it's like, and then that's late, right? When you're more than 10 minutes late for work, you're late now at this point. And so you're marked tardy. And that's same thing for a college class, right? So in the median, let's say the median, a minute and a half is not going to give you a tardy. You're not going to be late for work. But here, 14, 15 minutes late, you're late for work and you're going to be tardy. And so I think that's the way to think about it, to really grasp the concept of which value is more resistant to larger or smaller values or extreme values. Which one was more resistant? Which one hardly had any change? So the one that hardly had any change and was most resistant was the median. Right? The one that didn't resist, right? It's like, oh, I'm going to absorb all those minutes and I'm going to pull you up, right? And that average. And so that's exactly what the mean is. And the mean isn't too resistant at all, right? So here, let's go ahead and write it. Let me write it here. So the mean is non-resistant. And the median is known to be resistant. It's just known to be that way. And one good example is average income, in, let's say, California. We don't really say average income. We say the median outcome. And so the reason why we don't say the average outcome, income, because it's not a good reflection. If I took all those billionaires that live in California and millionaires that have houses in California, like Taylor Swift, Bill Gates, Elon Musk, those high-end income people, and added them up into the average households, like myself, that value is not going to be a true reflection of the middle class. But if I sort them, yeah, here's a bunch of high-end people, but if most of the data is middle class income, then that median, the middle, is going to be a true reflection of, well, this half makes more than this value, this half makes less than. And so when we always search for average income, really mathematically, it's the median. And we're going to see why we're able to kind of interchange those two words a little bit in a few chapters ahead. So we have to wait for that. We have to leave some mystery. Okay, so here's the definition. So a numerical summary of data is said to be resistant if, and this is where we get our highlighter out, if extreme values, very large or small, relative to the data do not affect its value substantially. And we could see that the median was not affected substantially, but the average was in our previous example.